Good afternoon. My name is Steve Woolway. I'm the Business Development Manager for Trelleborg Marine Systems in Melbourne, Australia. And this afternoon I'm going to basically provide a very brief presentation on a comprehensive approach to FSRU docking and mooring systems. First, I'd like to open with some general observations. This presentation is really going to focus on onshore, nearshore docking and mooring FSRUs. And really the reason for that is the majority of projects that are coming on stream right now are these small-scale LNG projects. The larger, what you find with for example, the Prelude project, that went through 3 years of feed and everything else, but what we're finding with the small scale, why it makes it more interesting, is they happen very, very, very quickly. Also what we're finding, especially with the onshore and the nearshore, these type of applications become actually far more complex in a lot of ways than a true offshore docking and mooring arrangement. And the reason for this is what you find with an FSRU is it tends to be semi-permanently moored to a nearshore structure or a conventional onshore jetty. And the FSRU basically is almost like a bridge between marine design practices and civil engineering design practices with the structural side. And what you tend to find is a disconnect or a potential disconnect because the two docking and mooring systems, the one between the jetty and then the one between the FSRU and the LNG carrier, basically become more or less looked at independently. And what you also find is you get with, for example, the mooring system between the LNG carrier and the FSRU. Typically, the FSRU is either a converted LNG carrier or it's a purpose-built FSRU. But from a shipbuilding standpoint, the shipbuilder is just primarily focused on what his specification is. And that scope of that specification, he does not look beyond that. His role is not that of the overall system configuration. Conversely, we basically have the exact same problem when we're dealing with the jetty or the structure, or let's say the mooring structure of this nearshore structure, because it typically is treated more like a civil engineering activity, and you typically don't have class involved. Basically have other bodies that are basically providing design guidance. And again, when it actually goes out to tender and the earth moving contractor or their civil engineering APC only looks at their scope of work and goes no further. So the not so subtle point of this presentation is the total system has to be really considered in its entirety if you basically want to have it operate efficiently and operate safely. Now I'll go into a little bit more detail because I'm using the word system a bit loosely, but the system includes mechanical elements, instrumentation, and control and monitoring, and a number of subsystems that are integrated into the control and monitoring side. Now I've put this diagram up to be able to talk to something, and this is probably the most simplest arrangement you'll find with a floating regas project. And what I'll elaborate on in a moment is really that's a bit of a bit false, because what we've found, and we've been involved in about 90% of all the floating regas in the last 4 years, is no two projects are the same. Now I'll just talk through this very quickly. What you see here is basically the jetty with the dolphins. And what you have is this is now the mechanical side of it, where we have the quick release hawser hooks. See these on basically on the dolphins across here. And that is what's semi-permanently mooring the FSRU alongside the structure. Then as you move across from the FSRU to the ship-to-ship mooring with the LNG carrier, you more or less duplicate the same quick release hooks on the FSRU. And you see these across here and here. And then we basically have the fender davits and the pneumatic fenders, obviously, to protect the two vessels. Now, one thing I want to point out, and this is where the mechanical side of this is pretty straightforward. Everyone, who's in the marine industry understands, really the hardware side of this. But where it starts to become more complex, because what we're dealing with are, these are not these aren't bollards basically. These are hawser hooks, which can be remote released, and they're also, with LNG carriers in the LNG industry, it's pretty much standard practice to have these things fitted with load cells, so you're able to monitor the actual mooring loads dynamically. Now, what's interesting to point out here is this is like a Q-flex, and this is more or less, one of the old ladies, probably 125,000 or 130,000 cubic meter Moss-style LNG carrier. But what you see is you end up with the inbound LNG carrier, you end up starting to basically sharing mooring systems. So what I wanted to point out here is where we have actually on several projects seen this overlooked, is because you have the jetty contractors only looking at this. And again, within the jetty control room, I'll talk about that in a minute, but you have the smarts of that side of the mooring system. Then within the FSRU, you basically, the shipbuilder obviously is just looking at what they have to install here. And then again, the smarts of this part of the system are in the cargo control room of the FSRU. One crucial thing, and I've seen this repeated a number of times, is when the two systems get treated completely independently, probably one of the foundational or fundamental issues is how does the release system work? Under normal conditions, things are done in a very unhurried fashion. When the ship is basically undocking, getting ready to go, the master's in control, they, in a very orderly fashion, release the lines, basically, and they're being done remotely by the FSRU. But where people have tripped up is in an emergency release, and again, I'll talk about this a little bit more detail. There's a feature within the release system that in the event of, say, a fire or some other catastrophic failure where you need to get the ship away very, very quickly, there is a release all function that you can literally let all the lines go at once, up to 100% of the safe working load. But what we've seen is when you end up with a split system, we had one project where the FSRU only had control of its own hooks. The jetty had only control of its hooks. So what could happen in an emergency, and what we pointed out to the ship owner, or basically to the end user, is what's going to happen, because really this is semi-permanently moored. This is the transient vessel, and if you do a release all from here, you're going to release the FSRU, and the FSRU is still going to be more or less. So you can see this it's a small detail, but it's obviously pretty important. And this just very quickly, this gives a rough, diagrammatic of sort of the key components. What you have in the jetty control room is the local server, and that's the brains of it. So that's basically the subsystems are coming into there. So you have your remote release control is either via conventional push buttons or a mimic panel in the workstation. You also have your MetOcean data coming in here. You have some of the field instruments. This is your more or less the weather station. It also interfaces from the sensors that are in the water. We typically either have seabed mounted sensors that are measuring wave height, tide, current direction, or sometimes they're actually mounted on the jetty itself. But you're getting all this data back into here. Then in the FSRU cargo control room is similar devices, with the addition of, we have GPS antennas because that's part of our berthing system. And basically what we normally use in a conventional LNG terminal is lasers, because obviously you have a stable platform on which to mount the lasers, and that's for basically the berthing aid system. So 200 meters out, as the LNG carrier comes into a typical LNG berth, You have a display board on the jetty, and then you basically have very similar to ECDIS electronic charts in which you can see very, very accurately the position of the vessel to the jetty. We are not able to use lasers on an FSRU because it's obviously a dynamic platform. So what we're using is RTK GPS, which is accurate down to about 2.5 centimeters. So that's more than sufficient. So that's mounted typically on top of the cargo control room, and then we have a UHF antenna because what we're able to, through telemetry, we can also send out load monitoring data to the deck officers, so they're able to always monitor what the loading of the mooring system is. And again, we have a remote release panel and then the workstation. Now I want to talk about more, that first diagram I said was sort of a fantasy world, because the reality is the majority of these projects, the location of I would say the location and the configuration of the jetty or of the structure is driven by environmental considerations, also driven by the location of basically where they want to have the regas operations. So I'll talk through just these, kind of give a, I'd say a good overview of sort of a flavor, because again, you see different variations of these. Dubai LNG was the first regas project in the Middle East, in which basically a conventional LNG jetty was used. The Golar Freeze was converted from a conventional trading LNG carrier to an FSRU, and it's semi-permanently or more or less permanently moored alongside the jetty. And then you have the inbound ship, basically is ship-to-ship moored to the Golar Freeze. Petrobras is a little bit different. It's a finger jetty in which the Golar Spirit, again, was another older LNG carrier that was converted to regas. And then the inbound LNG carrier is adjacently moored across this structure. Then Golar Canor in West Java, that's a near shore. That's about 4 kilometers offshore, just off of basically West Java, and which this vessel is or really permanently moored alongside this. It's a piling type structure. And then again, the LNG carrier comes alongside the port side and basically transfers cargo to the FSRU. And then the Herc LNG, this was for the Medan project. It was starting out very similar to this kind of arrangement, but with more or less like a finger jetty arrangement. But it ended up getting relocated, and now the FSRU is basically single point moored. So the incoming LNG carriers will still do a ship to ship, but the key thing here, and this is the point I really want to make, is each one of these, the centralized control from a hierarchy or a hierarchical standpoint was in different locations. In this case, the controls, the jetty basically has the highest level of control over the mooring system and everything else. In this case, it was the FSRU. In this case, it was the FSRU. And in this case, it was the FSRU. And what that means when you start getting into these nearshore arrangements or onshore arrangements is where the control is drives a lot of the real detailed systems integration requirements. And this is where to really highlight what I said before about the importance of not fragmenting the system, because we have a project we're involved in with right now that I won't name who's involved because they'd probably be embarrassed. But the shipyard inadvertently became the system integrator. They didn't realize it. They thought, in fact, that they had gotten completely out of that side of it, and everyone assumed that the shipyard was basically pulling together all this because they had taken the hardware, the mooring hardware, off of this barge and it had gone to the jetty, but the jetty was unmanned, and the FSRU, or in this case it was FSLRSU, the cargo control room, that was it. And so these guys had no idea that, The mooring side was easy. It's just installing, mechanical hardware, and that was a big wake-up call for them. So it's really, really crucial to look at this holistically. Then and again, I'm limited in time, so I'm just going to kind of hit the high points on design considerations. As I mentioned, because the FSRU acts as a bridge, the compliance part of this starts to get a little bit nebulous. What you have is you basically have marine and civil engineering regulators and advisory groups involved. And basically, as you well know, Michael, that, basically the marine guys lose interest very quickly when it's on, basically not on the vessel. And it goes the same with basically SIGTO and OCIMF. But the big difference between them and class is class obviously is very intrusive. They want to have all your designs. They want to basically have your finite element. They want to know what materials, specs, and they're very intrusive. Where with the hardware that goes onto the jetty, there's no oversight. Sort of the more or less the advisory groups like SIGTO and OCIMF, they're composed of basically operators and oil companies and gas companies. So what they tend to do is give operational guidance without giving detailed design recommendations. All they care about is how the system is going to function and work. It needs to be safe, but they don't drill in. And we've had situations in which we've had mismatches of this. For example, is one of the quick release hooks that was mounted on an FSRU, where D&V is very clear about how you size that according to obviously the safe working load of your mooring lines, the displacement of the vessel. Where when you go onto the jetty, it's a little bit less crystal clear. And we literally had a situation where across basically a common mooring system, we had 125-ton safe working load hooks on the FSRU and 75-ton on the jetty. And you're going, guys, what are you doing? You're basically, the weak link is ultimately supposed to be either the winch brake or, it's supposed to be the mooring line at the very least. You now have made the structure in the jetty and the hook itself potentially the weak link. And as I mentioned, we're talking both on the jetty and vessel-based. Now getting into the instrumentation, control, and monitoring, as I mentioned, it's not just the remote release system and the load monitoring, which is actually the most straightforward part. We start looking at the integration of the MetOcean and also the berthing aid system into a common workstation, so it's very, very efficient, easy for the operators to, for their decision making. And then also the key thing is being able to share this across a networked environment. So if you do have an office on the jetty, if you do have a remote location, say we've had instances in Brazil where the client wanted in their more or less in their admin office to be able to see the same data that was being basically viewed on the jetty, on the FSRU, and on the LNG carrier. So it becomes a bit complex when you start looking at that, because then you get into the whole thing of, who requires monitoring system data and what data is required. Because you have seafarers involved, you have process operators, you've got basically a mix on the FSRU of seafarers and plant operators. So getting all this information across in an efficient and easy way, instead of having literally 6 different workstations in which you have to look at to basically make, in some cases, very quick decisions when something's not going right. And then the key element when we talk about the control side is, again, the assurance of the control of the emergency release process. Now I'll wind this up, just sort of who we are and what we do. We're the business unit I'm in. We're really completely focused on safe berthing and mooring solutions in what can be a very demanding environment. And where we're somewhat unique compared to others in our field is basically we've been involved since 1980, so almost 40 years. Within the LNG world, we have basically 50% of all LNG jetties have our systems and our equipment. So we have a long history in this industry. We are the world leader in these instrumented quick release hooks. And then probably the thing that we take a lot of pride in is we don't subcontract out anything. We basically have all the engineering expertise in-house, and that's mechanical, electrical, instrumentation, the controls people. Our software that we use is basically proprietary, so we have the software engineers in-house. And then once we win the project, we control the whole procurement process, the manufacturing, and then basically our QA umbrella is over everything. Versus with some of our competitors, they're subcontracting out and buying in different elements. So from an owner's standpoint, you end up having the comfort that if you have a problem, you only go to one person. From a warranty administration, you go to one person. And then probably most importantly, throughout the life of the project, once it's completed and commissioned, you have one after-sales service group that you contact to take care of literally everything. And with that, I will end my presentation, and thank you for your attention. Any questions?